So statements within the braces are referred to as block of code or statement block. Uh, Across programming languages, programmers use a word compound statement, which is the same as block of code, because you can see in my little, you know, demo here is that yes, indeed, there is a combination of two statements between the braces, and that's expected to happen. That's why we have blocks of statements, because we expect to be typing even more statements, and that's how we code the program. Okay. All right. Java identifiers. We have some identifiers in this program. This is an identifier right here, the name of the package. The name of the class is an identifier. Main is also an identifier of the main method, which makes our class runnable. System is an identifier, which was done not by us, but by the Java library programmers, and they decided to name this particular area system. Out is also an identifier. Print line is, of course, the name of the statement, so it's also an identifier, the name of the statement. Hello and bye are not identifiers. They are literal strings, just you know, text expressed in the program as is directly, and it's called string literal. And we will discuss strings in the future. Now, those FAFSA words of non-existing things, you know, from the compiler standpoint, would be looked at as some sort of an identifier. And if I try to save this program, which is already saved, and try to maybe compile it, I can say, let me see, I think on this line right here, I can say build. Okay, I can specifically say that I want to build my project and not execute it. Like this button here typically builds and tries to run it in debug mode, but this option, right click, gives you option to build. There is also an option to clean and build. Sometimes when you do a lot of changes, rearrange the location of your packages, do a lot of refactoring, renaming your classes, so there's significant effect on what's happening in your code. Sometimes you want to clean everything that was previously built and rebuild from scratch. Because by default, if you have like 25 classes and 25 corresponding files in your source directory, if you really change just one file and try to recompile, Java compiler will compare timestamps on the source file and timestamp on the class files that were already compiled with the ready-to-go bytecode. And if there is no need to recompile, it'll run much faster because it's not going to recompile everything. But if you want to force it to recompile everything, sometimes you can get strange errors related to this stuff. You want to clean and build. And then there's also simply clean, because perhaps maybe you want to save your project and you really want to just get rid of anything that's compiled and save only your source code. There's a way to clean it as well. So what I'm going to say build, which I already did, and look what happened. Because those were not defined, those FAFSA words here, right? So it gives me an output with some error messages. Now I can increase the size by saying larger font, control plus equals, control plus control plus equals, so that it's easier for you guys to see. It tells me some informative messages, but then it says error cannot find symbol, right? And it says the symbol is variable FAFSA thing, right? And obviously this is like a cat walking on the keyboard, right? So FAFSA came just right out of that. So obviously it says I cannot find that symbol, but make no mistake, Compiler thinks of it as an identifier, and apparently an identifier of a variable. It just guesses, look, it has to be a name of a variable. Syntactically, it cannot be anything else. We have yet to talk about variables. We haven't created a single variable. But just to kind of go back to the origin of this discussion, that Java identifiers identify methods, classes, packages, and variables. So there are valid and invalid identifiers, and we're going to discuss that. So you can be thinking that, oh, I could use this name of variable, but it may not be accepted. So we need to discuss that. But before we move on any further beyond this particular point, with this kind of strange example that doesn't compile purposely, doesn't compile. My strong advice to you is, compiler can give you multiple errors. And did you remember when I ended up with this? It's all scrollable, and it's like it's going to tell you something in this window. What I would suggest, you scroll all the way up, go to the first error message where it says error, and you see how it appears to be like a link to the source of the error, to the line where it took place. Click that, and it basically jumps on the source code editor to that particular location, and even gives you those helpful tips saying cannot find symbol, which is the name of the variable it thinks, which is undefined, and ignore anything else below this first error message. It's a rare case when you cannot identify the source of the problem, and you have to kind of look beyond that first error message. But typically you can get a lot of error messages because compiler uses this technology that it tries everything possible to recover from error and keep on going to give you the report of multiple errors. Because if you have, depending on the complexity of your project, there could be multiple files, multiple changes that you made. It just doesn't make sense for the compiler to stop immediately after seeing the first fatal error. For professional people, it wants to print the whole report on what it can possibly find. So when it encounters an error, it sort of ignores, in my case, that, oh, okay, it seems like an undefined variable, but I can continue because the rest of the syntax is more or less okay. So it tries to find more problems and give me an information. In our cases, ignore the rest of it. Find the first error message and make sure you fix that. Then you compile again, move on to the next error if you happen to get one. Okay? Hopefully that makes sense.